Imagine living inside a city of 5,000 people that has no roads leading out of it, no garbage trucks, no sewage pipes connecting to anything on shore, no water treatment plant drawing from a river, and no way to call for help if any of it fails. And now imagine that city is moving at 30 knots through open ocean, surrounded by nothing but hostile water in every direction, and that it hasn't seen a port in 63 days. That is the baseline condition of an aircraft carrier on deployment. Not a ship that resembles a city, an actual functioning city with its own power grid, its own water supply, its own medical infrastructure, its own food production chain, and its own waste management system, all engineered to operate in complete independence from every external resource that the modern world takes for granted. And the question that almost no one stops to ask, the one that matters more than the aircraft or the weapons or the flight operations, is this: what happens to everything 5,000 people produce, consume, and discard every single day when there is nowhere for any of it to go? To understand why waste management on an aircraft carrier is not a logistical afterthought, but a foundational survival system, you have to first accept the scale of what you are dealing with. 5,000 people eating 3 meals a day generate somewhere in the range of 2,000 pounds of food waste every 24 hours. Those same 5,000 people produce hundreds of thousands of gallons of gray water, water from showers, sinks, and laundry, and tens of thousands of gallons of black water from toilets every single week. They generate hundreds of pounds of hazardous waste from aviation maintenance alone, including spent hydraulic fluid, used lubricants, cleaning solvents, contaminated rags, and heavy metals that cannot, under any interpretation of maritime law, be discharged into open ocean. They produce metal scrap, glass, cardboard, plastics, rubber, medical waste, expired ordnance components, worn aircraft parts, and the accumulated debris of a self-sustaining industrial civilization operating inside a hull that is roughly 1,000 feet long. If you were here, if you were one of the sailors pulling a maintenance shift in the depths of the engineering spaces at 2 in the morning, you would understand that the carrier's ability to function is not determined by its aircraft. It is determined by its ability to process, contain, and manage what those 5,000 people leave behind every hour of every day. Here is what most people never consider. The moment a carrier leaves port, it enters a category of regulatory and operational reality that has almost no civilian equivalent. It is simultaneously subject to international maritime environmental law, United States Navy regulations, and the engineering constraints of a vessel that was designed to be self-contained for months at a time. It cannot dump raw waste overboard. It cannot accumulate indefinitely. It cannot transfer waste to another vessel unless that vessel is specifically equipped to receive it. And it cannot wait for a convenient moment, because there is no convenient moment on a carrier. There are only flight operations and maintenance windows, and the relentless arithmetic of 5,000 people generating waste faster than any single system can process it unless every system is working exactly as designed. This is where civilian logic collapses. On land, waste is someone else's problem the moment it leaves your bin. On a carrier, waste is permanently your problem because there is no one else. The first layer of the system is the one most people would recognize if they thought about it: food waste. The galleys on a carrier operate around the clock, feeding sailors in rotating shifts, which means the waste stream from food preparation and consumption never stops. Potato peels, coffee grounds, meat trim, spoiled stores, returned trays, cooking grease, all of it must be processed in a way that prevents biological contamination of the ship, that prevents odor buildup in confined spaces, and prevents the attraction of pest species that could compromise both the food supply and the health of the crew. The carrier uses high-temperature waste disposal units, essentially industrial incinerators, to reduce organic food waste to sterile ash that occupies a fraction of its original volume and can be safely stored until port. These units run continuously and require dedicated personnel to operate and maintain. If a unit fails during the peak of a long deployment, the backup capacity is limited, The storage space for unprocessed waste is extremely constrained, and the biological and morale consequences of improperly managed food waste in a sealed environment with 5,000 people begin to compound within hours. The smell alone in a tropical climate, with no ventilation to the outside, becomes a command-level problem faster than almost any other single failure mode. And this is just the food. Beneath the food waste system, and far more technically demanding, sits the gray water and black water management infrastructure. Every shower, every sink, every toilet on the carrier feeds into a collection and treatment system that must process hundreds of thousands of gallons weekly without any connection to shore-based infrastructure. The carrier uses a combination of biological treatment, chemical processing, and mechanical filtration to treat black water to standards that allow it to be discharged overboard in certain conditions, specifically when the vessel is more than 3 nautical miles from shore and moving. When the carrier is operating in restricted zones near coastlines, in port, or in environmentally sensitive areas, no discharge is permitted at all, and every gallon of processed and unprocessed waste must be held on board. If you lived here and you watched the ship's position on a chart during a restricted water transit, you would understand what the engineers in the sewage holding spaces are thinking. Every hour of transit is another hour of accumulation, and the holding tanks have finite capacity. A miscalculation in the deployment schedule, an unplanned port delay, an extended restricted zone, a longer than projected mission, stresses the entire system in ways that ripple upward through the crew's daily experience long before it becomes a formal emergency. The pressure is quiet and constant and invisible to almost everyone except the people responsible for managing it. But this creates a new vulnerability. And it is one that most analyses of carrier operations never reach: hazardous waste. An aircraft carrier is, among other things, a floating aircraft maintenance facility operating at industrial scale. Every aircraft that lands and launches generates waste, hydraulic fluid that degrades and must be replaced, lubricants contaminated with metal particles, cleaning agents used to degrease engine components, solvents used to remove paint and corrosion, batteries, electronic components, fuel contamination, oxygen system components, and the spent materials from the constant repair cycle that keeps aircraft operational in a saltwater environment that is aggressively hostile to every material an aircraft is made of. None of this can be incinerated in a standard food waste unit. None of it can be discharged overboard under any conditions. All of it must be categorized, labeled, containerized, and stored in dedicated hazardous waste storage areas that are fire-suppressed, ventilated, and isolated from other systems, because a chemical fire in a hazardous waste storage space on a vessel with no fire department to call and no escape route that doesn't involve open ocean is not a containable emergency. It is a cascading catastrophe. The hazardous waste storage system is therefore not a convenience. It is a survival architecture. It accumulates throughout the deployment and is offloaded only when the carrier reaches a port with the specific infrastructure to receive it. On a 6-month deployment with limited port calls, the volume of hazardous material that must be safely held on board would fill several tractor trailers. Every cubic foot of storage space on a carrier is contested, and hazardous waste competes with aviation spare parts, medical supplies, food stores, and ordnance for space in a hull that has no room to give. And this is where the pressure intensifies, because running beneath all of these individual waste streams is the machinery plant, and the machinery plant generates its own category of waste that is in some ways the most consequential of all. The carrier is powered by nuclear reactors. The reactors produce radioactive waste, not in the dramatic quantities of civilian nuclear facilities, but in a steady, constant, unavoidable stream of low-level radioactive material, contaminated filters, spent ion exchange resins, protective clothing worn by personnel working near the reactor, contaminated tools, and the processed water from the reactor cooling systems that carries trace radioactive contamination. This waste exists in its own category, governed by its own set of regulations, managed by its own dedicated department, the reactor department, and stored in its own sealed spaces with its own monitoring systems. The sailors who work in and around the nuclear spaces are radiation monitored throughout their service. Their dosimetry records are permanent. The waste they generate is tracked at the component level. Nothing in the nuclear waste stream is approximate. If you were here managing this system, you would understand that the margin for error is not small. It is definitionally zero. Because radioactive contamination of the ship's water supply, its food handling spaces, or its crew spaces does not produce a manageable problem. It produces an event that ends careers, triggers international incidents, and potentially renders the vessel non-deployable. The nuclear waste system is the one part of the carrier's waste management infrastructure where the consequence of failure is not measured in discomfort or lost efficiency. It is measured in permanent harm to human beings and permanent damage to the mission. Here is what most people never consider when they think about this system in aggregate. All of these waste streams, food, gray water, black water, hazardous material, nuclear, are being managed simultaneously by different departments with different regulatory frameworks, different storage requirements, different processing technologies, and different failure modes inside the same hull while the ship is also conducting flight operations. While personnel are sleeping in 12-hour shifts in berths stacked 3 high in compartments the size of a living room, while maintenance is being performed on aircraft that cost $100 million each, and while the command structure is making real-time decisions about where the ship is going and how long it will be there. Waste management is not a background function on a carrier. It is a primary operational constraint that shapes deployment planning, port call scheduling, replenishment at sea timing, and the daily work schedule of hundreds of sailors whose job titles contain no reference to waste at all, but whose work is directly structured around keeping these systems functional. The supply officer knows the holding tank levels. The executive officer knows the hazardous waste inventory. The commanding officer, when planning a transit through restricted waters, is calculating, among a dozen other variables, whether the sewage holding capacity will last. If this failed, if the primary waste processing systems went down simultaneously during a long deployment far from any port, the sequence of consequences would be systematic and predictable and deeply unpleasant. Within the first 24 hours, food waste storage would reach capacity and the galleys would have to reduce production, beginning the rationing math that every carrier cook fears. Within 48 hours, gray water holding tanks would be approaching limits, and shower frequency would be restricted. Not a comfort issue on a carrier, but a hygiene and morale issue with measurable effects on crew performance in high-stress operational environments. Within 72 hours, the commanding officer would be in direct communication with Fleet Command about an emergency port call or emergency replenishment, and every operational plan in the region would have to be revised. The carrier would not sink, the crew would not die, but the mission would degrade. The psychological pressure on 5,000 people living in close confinement without normal waste removal would build in ways that have been studied and documented by military psychologists, and the machinery of order that keeps that many people functioning cooperatively in a sealed environment would begin to show stress fractures. Order on a carrier is not natural, it is engineered. And the systems that maintain order are not the rank structure or the regulations. They are the water and the food and the air and the waste management infrastructure that make it possible for 5,000 people to live in a space where no reasonable person would choose to live, and to do it for months, without the environment itself becoming the enemy. What makes this system genuinely remarkable, what elevates it beyond the category of engineering achievement into something closer to a philosophy of design, is the principle that underlies every decision in its construction: the assumption of abandonment. The carrier is designed on the assumption that it will receive no help. Every system is sized to function without resupply. Every backup is sized to function without the primary. Every storage space is calculated to hold what the crew will generate before they can offload it, with margin. The ship is not prepared to be self-sufficient as a contingency. It is designed to be self-sufficient as its fundamental operating mode, with resupply and port calls as bonuses rather than necessities. This is the design philosophy that separates a carrier from every other large vessel on the ocean. Not its aircraft, not its weapons, not its size, but the depth of its self-containment, the completeness with which it has internalized every system that the modern world outsources to someone else. And the waste system is where that philosophy is most legible, because waste is what remains when everything else is done. The residue of 5,000 lives being lived in full with no shore to send it to. The carrier handles it anyway. It was built to. What the carrier's waste management system cannot tell you, the question it leaves open, is what happens to the human beings inside it over time. The engineering answer to waste is solved. The systems work. But there is a quieter question underneath it, about what months of living inside a managed, contained, zero-margin environment does to the psychological architecture of the people who operate it, and whether the same design philosophy that makes the physical system self-sustaining also shapes, in ways that are harder to measure and harder to document, the inner life of the crew. That question belongs to a different system entirely, one that has no holding tank and no processing unit, and no guaranteed way to offload what accumulates.